Good evening, ma'am.
Yes, good evening, Harish. Good evening.
Good evening, ma'am.
Good evening, Pranav. Harish, in previous class, what we had discussed, we had about patterns we completed, right?
Means we have more patterns, I think, ma'am. Means exercise completed, ma'am. One exercise.
We completed the exercise, first exercise we completed. We need to go with some part of
Yes, ma'am. Exercise
other patterns. Yeah.
Yes,
There are
ma'am.
few more patterns in. Okay.
Yes, ma'am.
Yes, Pranav is here. Pranav, can you please say about the pattern? We discussed many patterns, right? Among that, what is the formula to find? What is the pattern to find out sum of n natural odd numbers? Sum of n natural odd numbers. Pranav, we discussed many sums, right? Many patterns we discussed. What is sum of n odd natural numbers? Sum of first n odd natural numbers. Is sum of first n odd natural numbers. Harish, can you please?
Now what, ma'am? What are you saying?
We discussed many patterns, right, in previous class. Among that, what is the sum of first n odd natural numbers?
Ma'am, I not joined that class, ma'am.
You're not there in previous class?
Ma'am, not previous class, that previous class. Means
But continuously 2 classes we discussed, right? Okay. Hari Karthik is there in the classroom? Hari Karthik. Hari Karthik, what is the formula to find out the sum of n first n odd natural numbers?
Ma'am,
Suppose
can you repeat again?
Sum of first n odd natural numbers.
Yeah, the formula for that,
Yes.
ma'am, I don't know the formula, but I know that the sum of the first.
Okay. Anything.
Yeah,
Suppose.
Ma'am,
Because
n
we
square,
discussed
n square.
n square, right?
I mean, like
1 plus 3 plus 5 plus 7 plus 9 is equal to how much, children?
5 square or 25.
five square.
Very
ma'am.
good, Pranav. Pranav, good. It's n square. So n, what is n? These are natural. How many natural numbers are there? Please count it.
5, ma'am.
1, 2, 3, 4, 5.
5.
Yes, 5 natural numbers. So 5 natural numbers means which is 5 square. What is the value of 5 square?
25.
25. 5 square is nothing but 5 into 5. 5 5s are 25. Same way, what is the sum of first 9 natural numbers?
9 square or 81.
Yes,
Ma'am, it's 9 square or 81.
yes, 9 square, which is 81. Right, very good. Right, children, just count the number of
Okay,
odd
ma'am.
numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9. So first
Right.
n odd natural numbers is nothing but the formula is n square. 1 plus 3 plus 5 plus and so on. Adding n natural numbers. We will get not n here. N natural numbers we will get n square.
10 square.
This is the pattern, very important pattern we discussed in previous class. Not only this, we are doing many things, children. Triangular pattern, the sum of 2 consecutive triangle number is a square number. We discussed what are the, yes,
Ma'am, does this work for the formula n plus 1 square minus 5?
what, ma?
It's the same, right? N plus 1 square minus 5. It is the same formula, right?
Which one, Harikarthi? Sum of first n odd natural numbers is
for
nothing but,
Ma'am, for that we can also use this n plus 1 square minus 5.
yes, n plus 1
Square.
square minus
I mean, n plus 1 whole square minus 5.
n plus 1 whole square is n square plus 2n plus 1 minus n minus what you are telling minus
5.
minus 1. I think no, because if you look here, n plus 1 whole square minus 1. If you say this,
minus 5.
if you
Minus 5.
it's my 5. Okay. So n square plus 2n plus 1 minus 5. This is nothing but n square plus 2n minus 4. So this can be written as, no, we cannot write. It is not equal to n square, right, Harikarthi?
Okay, ma'am.
Yes, hope it is clear. Now, coming back to the part of these are first thing you can see there are other patterns we discussed. How many non-square numbers lies between the following pair of numbers? Suppose 90 square and 91 square. How many non-square numbers? 90 square and 91 square. How many non-square numbers lies
180.
between these?
180.
Very good. That's 2n. 2 times n. This is n square and this is n plus 1 whole square. The in between number of non-square numbers are nothing but 2 into n. So here what is the value of n? It is 90. So 2 into 90, this is 180. 180 non-square numbers. Very good. It's more important. Children, why I once again recollecting all the points, you forget the things that's more important. And not only that, the sum of consecutive n natural numbers. Sum of consecutive natural numbers. Sum of consecutive natural numbers can be expressed as a square number, right? How you supposed to express as a square number? Every square number can be expressed as a sum of consecutive natural number. That means suppose a number, suppose you take an example of 9. 9 square is 81, right? What is the value of 9? 9 square is 81.
81.
Yeah. How you can express as a sum of two consecutive natural numbers? Suppose here you take 9. 9 square as 81. How you can express as a sum of two consecutive natural numbers, children? What is the formula? What is the formula? N square minus 1 by 2. You look back to the part. So, if you want 3 square, how you supposed to represent 3 square minus 1 by 2 and 3 square plus 1 by 2. If you go back, what is 3 here? N square minus 1 by 2 plus n square plus 1 by 2. What is n square, children? N square is whatever the given number. N square is 9. 9 square, 81 minus 1. 81 minus 1 is 9 square minus 1 by 2 plus 9 square plus 1 by 2. So here 91, 9 square is 81 minus 1 by 2 plus 81 plus 1 by 2. This is 80 by 2 and 82 by 2. So this is all again can be 80 by 2, half of 80 is 40 and 41. These are the sum of consecutive. Not only this, children, any number, any square number can be expressed as a sum of consecutive numbers. So how you suppose 11 square. How you can represent 11 square? Half of 120, because 11 square is 121. Half of 120 is 60. 60 plus
61.
that's all. That's more interesting thing. This is one more pattern we discussed. Not only this, children, we are going with the product of two consecutive odd natural numbers. The product of two consecutive odd natural, even or odd, either thing. Odd natural numbers is nothing but how you suppose.
Ma'am?
Suppose here, yeah.
Ma'am?
Harika,
The above rule you explained, like you told that any square number can be written as the sum of two consecutive numbers, right? This only
Not
applies to
odd square numbers.
Okay, ma'am.
Odd square numbers, not even square numbers. Some of odd square numbers can be expressed as sum of consecutive numbers.
Okay, ma'am.
Not only we cannot take even cases. This is only applicable for odd square numbers. Hari Karthik, hope it is clear.
Okay, ma'am.
That's particularly for odd square numbers. Coming to the, in this case, you can go with either odd or even. Product of two consecutive even or odd natural numbers can be how you supposed to express as a square numbers. Let me see. Here, any consecutive odd numbers. Anything, you can take any number, children. 19 multiplied with what is next consecutive number, consecutive odd number, children?
21.
19 after, huh?
21.
21. So what is the middle number between these?
20.
20. This, the
It's
result
20
is
square minus
20 square minus
1.
1. 20 square. How it is? Because this already we used this law of identity. Children, how we know that 19 can be written as 20 minus 1. 21 can be written as 20 plus 1. This is once again which is in the form of a minus b into a plus b identity. This is not coming from anywhere. This already we know this. A minus b wholes a minus b into a plus b can be written as a square minus
B
a square minus b square. What is a here? 20. 20 square minus 1.
1.
So this is the way. Not only odd cases. If you go with even number of cases, also same thing. 12 multiplied with 14.
12.
Yes. 12 multiplied with 14. Can this number, can we write it as 13 minus 1 into 13 plus 1? Yes or no?
Yes, ma'am. We need
So
to
this can be written as a minus
A
1
minus
into
two.
a plus 1.
take one.
This is nothing but a square minus 1 square,
One
right?
square.
A square minus 1 square is nothing but a square minus 1. So 13 square minus 1.
One.
So this is the value we can write 13 square minus 1. Generally in real number you can consider and do as a pattern. But this is not, we know this pattern long back we are using from class 6 onwards. But particularly they mentioned this is one identity, a product of two consecutive odd or even natural numbers can be expressed as square numbers also. That is one more interesting. Not only those, these are, we already discussed how many ones are there, that many times you increase then decreasing order. It's a triangular pattern.
We did.
Same thing with the 6 and we completed the exercise part.
Yes.
These are the things, and today's class we are going with the finding the
Ma'am,
square of the
Not
number.
completed full, I think, ma'am. Exercise.
Yes, ma.
Ma'am, completed, ma'am. Nothing, I think.
Huh. Yes, Last Priya is a new student. Last Priya, are you there, ma?
Yes, ma'am. Yes, ma'am.
This is first class, my dear.
Yes, ma'am, it is.
Yeah. Hope you are able to follow the things. We are not starting only the thing what we discussed only previous class. What are the things we are just you are able to catch the points, ma? Any difficulty
Yes,
here?
ma'am. I'm able to understand, ma'am.
Okay, right, good. Right, children. Coming back to the finding the square numbers. Finding the square numbers also not a new thing, but in particular case, what is in our textbook? Suppose you want to find out a 23 square. You want to find out 23 square. How are you supposed to find out 23 square, children? Generally, what is the value of 23 square? 23 can be written as 23 into 23, because square number means we are multiplying the same number twice, right? Now,
Ma'am, I
this
have
20,
ma'am.
yes, ma'am. Please, 23 can be written as 20 plus 3.
3.
Here 20 plus 3, right? So we know that any number, we are multiplying a number means the first number with the complete pattern, second number with this part, right? So 20 multiplied with 20 plus 3 and the second plus 3 multiplied 20 plus 3. So what we are getting 20 into 20. 20 product multiplied with 20 and 20 multiplied, because this is distributive property again. Bracket outside number can be distributed both the numbers inside the bracket, right? So
Yes.
3 into 3. Now here 20 into
400.
20. 400, very good.
Yes.
Coming to 60 plus 60 plus 9. 9. This is 400 and plus 60 plus 60, 129. 500 and
520. 1.
oh no, 529. That's all. Right. 529, right. Right.
Okay.
This is the way in this
Yes, ma'am.
they expanded and they gave children. Generally, in our class 7, we know this. How you know 20 plus 3 can be written as 23 can be written as 20 plus 3, right? Which identity we can use?
Yes, ma'am.
Which identity we can use?
Ma'am, we can write 529 of the left side.
No, I'm asking you. No. Yes, ma'am.
Distributing.
Yes, Lasipriya, yes.
Distributing.
No, this is, what is this? Yes, someone said, can I say, who is that?
Ma'am, I did not say, ma'am, but I'm trying. Ma'am, we should do 20 square and 3 square. We should write like that. We need to distribute them. 20 square is something and 3 square is 9.
No.
Ma'am,
Someone is asking, ma'am, can I say, please say the answer, ma? Any identity we can use here?
ma'am, A square plus B square.
Very
Yes,
good.
but-
It's not A plus B whole square. Very good. Someone said Harshit, I think. Very good, Harshit. A plus B whole square, Harshit. What is the identity? A plus B whole square can be written as?
Square plus 2ab.
Yeah, 2ab plus b square, or you can write in any way, children. The C children here, why we are getting 62 times means this is the middle term, 2 times AB. 2 times AB, this is 20 into 20 is nothing but a square term. 3 into 3 is b square term. Even you can use this identity to solve the part of question. Someone mic is unmuted, please mute your mic or else I'll remove from the group. Right. Thank you, children. Because this is we are not one here. We are multiple students. Please follow. Can you please find for 39 and 42 the same way, children? Can you please find for 39 and 42? Use your own way. 39 square and 42 square. Come on, children. Please through chat box you can answer. Find the values of 39 square and 42 square. Hurry up. 39 square and 42 square. Everyone, please solve it, and through chat box you can answer 39 square and 42 square. Either you can use this way or you can use your identity. You can find the square of 23. Sorry, 39 and 42. After this, we are going very interesting pattern. Really, it helps a lot, but there is a limitation for the pattern. That's really good pattern, children. You can enjoy the pattern. Yeah, I got answers from my students. The first given answer is Hari Karthik. Very good. Harish given second. Very good. Both are correct. Yes.
Second question, can you show? Second.
42 square better. 42
42.
square. Both
Okay.
42. 4 to 42. Yes,
Okay.
Harshit. Hari Karthik given both first. Then Harshit given the first one. Very good, Harshit. Harish also given correct answer. Harshit also given correct one. Very good. Good, children. Good. Others, please. Pranav, Arush. Are you doing the session, or else you are not getting anything, any response from you? Okay. Okay, Pranav. Harshit, please check beta once. The second one. 42 square, please check Nana once.
Ma'am, I shall both, ma'am.
Yes, Harish, both are correct, Harish.
Okay, ma'am.
Very good. I'm waiting for other students who are not yet responding to the class. Hari Karthik, Harshit, Harish, these are the three students are responding. Very good. I'm waiting for Lasya Priya's response. So Sriram.
Ma'am, 5 minutes, ma'am. I'll send it to you.
Okay, Pranav. Arush is not there, I think, in the class.
Yes, ma'am.
Very good. Hari Karthik,
Ma'am,
Harish,
it is square of
Harshit. Okay, 1 minute. Yes, Lasya Priya, any doubt, ma?
Ma'am, in the third one, there's 20 into 20. Can you explain that one once?
Okay, 39 square and 42. Which one you want, ma?
39 square.
Okay. 39 square I will help you so that you can do 42 your own, okay?
Yes, ma'am. Okay.
Good. That is the way you can learn. There is no need to fill. 38 square can be written as in different ways, children.
39, ma'am.
39. Okay, sorry. Ma'am. Anything, any number square. 39 square can be written in both the ways. Either you can write as 30 plus 9 whole square. This is one way. Or you can go with 40 minus 1. Anyway, you can 39. How you supposed to write, ma? 39 can be written as 30 plus 9, or 39 can be written as how you supposed to write even 40 minus 1. Yes, you can use any identity beta. A plus B whole square or A minus B whole square you can use. A plus B whole square can be written as A square plus 2AB plus B square. And A minus B whole square identity is A square minus 2AB plus B square. These are the two identities we can write, Harshit. Yes, Nana, correct. Okay, fine, not an issue. Then you are anyway use 2 bits. Right. Now, which identity, Lasapriya, we can use the first one or second one? Your choice, beta. You can take your own choice. Which one we can use?
Ma'am, we can choose any of those.
Okay, both answers we will get. Both ways I will help you. So you can try in any way. First, I will use identity as A plus B whole square. In second case, I'm using A minus B whole square identity. As we know that A square, this is A square plus 2AB plus B square. Here, instead of A, we have 30 and instead of B, we have 9. 30 plus 9 whole square can be written as 30 square plus 2 into 30 into 9. Plus B square means 9 square. Plus B square means 9 square. Just I am replacing the values in place of ABs. So 30 square can be written as 33 square. 3 square is 9. 30 into 0. So 900. So 2 3s are 6. 6 9s are 6 9 times 54, right? 540. 54. The 0 is added here. So 540. 9 square is 81. So 900 plus 500, 1400, 1400 plus 40, 1440, 1440 plus 81, 1440, 1440 plus 81. Do in your mind, children, or else 1,
1521.
Good. 1521 is the answer. This is first way we are doing. If you use second identity, we know that A square minus 2AB plus B square. So minus identity where this is the way. So here A value is 40, B value is 1. So 40 minus 1 is 40 square. And B is 2 into A is 40, B is 1 plus B square means 1 whole square. Come on, children, 40 square means 60 is 4 square. 16, 40 square, 1600. 2 times 4, 2 times 4, 8. 8 added with one more 0 here, extra 0 is there. 1, any number multiplied with 1, we are getting the same number. So 1 square once again. 1600 minus 80 is 1520. 1520 plus 1 is 1521. In either ways, we are getting the same answer, man. So 1521 is the answer. Right, ma'am, I don't know this both ways, but can you please, general way you can help. In that case also, we will do the same procedure. Lasapriya, general way is 39 can be written as 30 plus 9. Yes, 39 square means we are squaring 2 times of this number 30 plus 9 into 30 plus 9. So we know that any number, 2 numbers, this is product. The first number complete multiplied with complete second bracket, and second number is complete with the second bracket. So first number of your first one, 30 into 30 plus 9, and the second number 9 into 30 plus 9. Once again, it is distributive property. So which is 30 into 30, 900 plus 39 times 270. Same way here, if you distributed 9 with the 30, 9 into 30, 270, again 9 nines are 81. If you add all together, 900 plus 270, 270, 540. 900 plus 540 is 1540 plus 81. So 14, no. What is 900 plus 540? It's 1440. 1440 plus 81. 1440 plus 81. 1440. It's 1521, right? If you add up all together, it's once again 1521.
Ma'am,
Yes,
can you
these
check
are-
the
Yes, ma'am.
ma'am, can you check the chat? I wrote the answer.
Okay, sure. Okay, right. Right, classic. Yeah, very good. Correct.
Thank you.
Yeah, correct. That's all. Very good. That's all, children. I did not get still Pranav and Sriram. Sriram and Pranav not at all shared their answers yet.
Such question means they are not.
There is an interesting pattern. Really, you are very enjoying. This is a very beautiful pattern, children. But it has some limits. Only the digit, the number ends with 5. The number ends with 5. That is the only limitation of this pattern. Suppose whatever the number, suppose either 15 square or 25 square or 35 square or 45 square or 55 square.
It all
or
ends with 5.
any, yeah. Some wrong in my book, but I got clarified. Okay, right, Pranav, right. Please, 65 square, look this pattern once again. This is one more interesting pattern. 85 square, 95 square, any number end with 5, end with the number end with 5. If you want to make as a square that number, it's very easy task for you, children. So first, there is a 5. This is what is the first digit here? 1, right? 1 immediately, 1 after next number is 2. 1 2s are 2. 1 2s are, what is the value? 1 2s are 2.
2.
Plus, what is this 5 square? 5 square as 25, right?
25.
So the complete value of 15 square is 1 2s are 2, 2, 25. Here same thing, children. 2 immediately after 2. What is the number immediately after 2? 2 into 3. 2 3s are how much? 2 3s are
6.
6. So 6, 5 square is, well, 5 square is 25. Same way, 3. Immediately next number to 3 is 4. 3 multiplied with 4.
12.
3 multiplied with 4 is
12.
12. 12. 5 square is 25. 1 2 2 5. Same way, 4. 4 immediately next number is 5. What is 5 4s are? 4s are 20. 5 square is 25. So like that, any square number ends with 5. You can easily build the pattern, children. You can easily build the pattern. First number and next to the first number, consecutive number to your first digit. You multiply and just square of 5 square. So 5 into 6. 5 6 are 30. 35 square is 25. 6 7s are 6 7 times.
42.
42 25, right? 7 8 times. 7 started. Next consecutive number to 7 is 8.
56.
7 8
56.
56. So 5 6 2 5. Right. The same page in any number. Not
Yes.
only 2-digit number, even 3-digit number also you can try. You
No,
can
two-
check.
Yes.
It's 105 means 10 multiplied with 11. 10 multiplied with 11, 110. 5 square is 110. Not only 2-digit number, even you can try
Okay,
for a 3-digit number. This is a very interesting pattern and easiest pattern, but it is only applicable for the end digit of your number is 5.
fine.
Hope you understood, children. Can you please try these numbers? Can you please try 205 square? How much? Please text me. Please text me your 205 square and 95 square. Second bit and fourth bit. Can you please answer this second bit and fourth bit?
Ma'am, can you explain 105 once again? Sorry about that.
Very good.
105?
105. Yeah, sure. Sure, ma'am. 105 means what is 10? This is your number, right? First two numbers you can take here because it is 3-digit number. You need to take first two numbers. So 10 after what is your next number? 11. 10 into 11 is?
110.
10 into 11 is? 11 tens are?
110.
110, same base 5 square. Hope you
Ma'am.
understood.
Yes, ma'am, understood.
Ma'am, answer forwarded, ma'am.
Very good. I got answer from Harish. Pranav. Pranav, which bit you gave better? Pranav?
I went away for some time. What question are you asking?
No, I'm asking about the question is here. You just look here. The question is 95 square and 205 square. 95 square
Okay.
and 2.
Ma'am, ma'am,
Yes, I got answers. Very good. One of the student is 95. 95.
Ma'am, again, first one.
Hari Karthik, why you gave 9025 but you
No,
gave
ma'am, again, I
920?
gave the last, ma'am, there is nothing.
Okay, fine.
I gave the last.
Right, Pranav, correct, Hari Karthik, I got it, I got your message.
ma'am,
Harish, correct.
ma'am.
Even Lasya Priya, correct. Very good, Lasya Priya. Both bits, Hari Karthik and Harshit, both are correct. Lasya Priya, good. Pranav, first bit was given. I don't know which bit. 205, Pranav. Better Pranav. Pranav respond. 205 square, please. So 205 square. What are the first two digits here? 20. 20 immediately next number is 20 multiplied with 21. 21 twos are 420, right? Again 5 square is 25. But what is why you are getting 42, 4,000 something you are getting, right? Let me check. Pranav, check once better. Your 205 square is wrong. You see here, 205 means 20 is your first digit, right? I think as 2 digits because it is 3-digit number. 20 immediately next number is 21. Consecutive number to 20 is 21. So 20 multiplied with 21 is 420. Again 5 square is 25, which is 42,025, right? Right. Okay, fine, not an issue. Right, children, that's about one more interesting pattern. The very important pattern, Pythagorean triplet. Pythagorean triplet is, we already know that Pythagorean triplets we already learned for right angle triangles. Yes. What is Pythagoras property used in your class 7 children? It is applicable for right angle triangles. Yes. What is the Pythagoras property? Yes. What is Pythagoras property? In any right angle triangle, which is hypotenuse, which are the legs children. Let me take the back to the board. Pythagorean triplet is one more interesting pattern. Before going to that, we have some part of Pythagoras property we need to discuss here because we already have. All right. So if you take as A, B, C, which is right angle here, children, right angle at A. So which is opposite to right angle is hypotenuse. And the next two things, either sides. So these are the leg 1, leg 2, anything you can take, either leg 1. This is another two sides we can take as. What is the relation between legs and hypotenuse? Yes.
Ma'am, hypotenuse square is
Very
equal to leg 1 square plus leg 2 square.
Very good. Hypotenuse square is equal to leg 1 square plus leg 2 square. Very good. This is, we know very well about Pythagoras property in class 7 for right angle triangles. This is applicable for, we think this is applicable for only right angle triangles. Now in this class 8, we have Pythagorean triplets. How Pythagorean triplets can be identified means the same way, children, m square minus 1, 2m, m square plus 1. These are the three values. Based on this, we can find out the Pythagorean triplets easily. So how it is, how you supposed to find out Pythagorean triplets? Suppose let me take the values of the right angle triangle, which x are 2 and 3 and 4. Suppose this is right angle triangle. The leg is 3 centimeters. Another leg is 4 centimeters. What is the hypotenuse, children? We know that leg 1 square plus leg 2 square is equal to hypotenuse square, right? So here 3 square is 9, 4 square, 4 into 4 is 16 is equal to hypotenuse square. This 2 together 25 is nothing but hypotenuse square. 25 can be written as again 5 square is hypotenuse square. So square get cancelled. Hypotenuse is nothing but 5. Yes, this is 5 centimeters. This is well-known fact about the Pythagoras theorem, about the Pythagoras property. Now coming back to the question, can you please check 6, 8, 10 are Pythagorean triplets or not? 6, 8, 10. Come on, children. Always the largest side is the hypotenuse, children. Remember, always the largest side is the hypotenuse. Which is the larger hypotenuse among these sides? There are 3 measures given, 6, 8, 10. Which is the hypotenuse here?
10.
10, because the largest side is hypotenuse. Right. Pranav, good. So 10 square is equal to 6 square plus 8 square. Come on, please check it, children, whether it is true or not.
Yes, ma'am.
Yes. 36 plus 64. This is also together makes you 100. Yes. These are Pythagorean triplets. Like that, we are going to find few more triplets here, children, but they won't give whether it is a Pythagorean triplet or not. That's the easiest way we can check. Same way, can you please check 5 square and 12 square together 140, 169, which is equal to 13. So this is also a Pythagorean triplet. So based on this only we got the pattern like m square minus 1, m 2m and m square plus 1. So this right Pythagorean triplet whose smallest number is 8. Right Pythagorean triplet whose smallest number is 8. Which is the smallest among all these triplets, children? Either it is maybe, which is the largest one, which is the smallest one in Pythagorean triplet? M square plus 1 is the largest one, which is hypotenuse. Yeah, which is hypotenuse.
2m is
Yes,
smallest.
yes.
2m is the smallest one.
No, we are not sure about whether 2m is smallest or m square minus 1 is smallest.
2m is
Maybe
smallest.
either. So, but in this case, which one you are going to equate? That's more important, children. You have to think little logically here. You have to think little logically here because there are two options. We know that in Pythagorean triplet, m square plus 1 is the largest one. That's nothing but hypotenuse. Largest side is nothing but hypotenuse. We are not sure about m square minus 1 and 2m. Maybe either any one of these. Maybe we need to check whether which one. Our question is coming to the back to question. Write a Pythagorean triplet whose smallest number is 8. They did not mention. Maybe either 8 is this or maybe this. First, we will go with the m square. First case, case 1, we are going with first case, we are going with m square minus 1 is 8, where m square is 8 plus 1,
9.
which is 9. So m square is 3 square. So m is
3.
3. This is one case. Coming to second case, if I'm taking second case, 2m is 8. So m is
4.
4. M is 4. Now, which case our action will be true? You need to check, children. In which case? Either m square plus 1, the hypotenuse should get longest side, right?
Yes.
What are the triplets here? Yes, you are checking with first, the smallest number is m is 3 you are getting. Another case you are getting m as 4. But which case it is true? In first case, what is the value? We can find out separately for both the cases, children. In first case, you are getting m value as 3.
3.
M value as 3. What are the three things? M square minus m as 3 means, what are the triplets here? M square minus 1,
8.
2m and m square plus 1. These are the triplets. M square minus 1, 8 we got. 2m as 2 into 3. 2 3s are 6. And m square plus 1 means 10, right? Is it Pythagorean triplet? Did we check just before? 6
Yes,
square
ma'am.
is 36. 6 square is 36. 8 square is 64.
64.
10 square. Yes, it is Pythagoras triplet. Coming to the second case, let me check with second. So in this case, 2m value we got 2m as 8 and m square minus 1. 4 square minus 1 and 4 square plus 1. 4 square minus 1 is 16 minus 1.
15.
15, 8,
8.
17. Check once whether this is a Pythagorean triplet or not. Come on, hurry up, children.
289, ma'am.
Yes, 8, 15, yeah, 17. With 8 as the smallest, we are getting right. 8, 15, 17. Here 6, 8, 10. Both are Pythagorean triplets only. But according to our question, 8 is the smallest triplet. Among the three, which is the smallest one? 8 should be the smallest one. Which case it is true? Second case. So this is our requirement. So we are going with this is the correct one. Of course, it is also Pythagorean triplet, but we are not considering this. We are considering the second one. Because our requirement 8 is the smallest among the triplets.
18, 17 are triplet, ma'am.
Yes, that is also triplet. You can check beta. 8 square plus 15 square is equal to 17 square. 8 square is 64, 225, 17 square is 286. 289, right? 289. So if I added this 6 plus 5, 9, 24, 28. Yes, both are correct, Anna. Yes, both are triplets only. But requirement is very important. Our question is more important. Write Pythagorean triplet whose smallest number is 8. That's why we are going with the second condition. So here the smallest number is 8. Why we are not taking the first case? Here, what is the smallest triplet?
6.
6. That's why we are not taking this. Right, children?
17 square, 309, ma'am.
That's one way of asking questions. Sometimes they may ask Pythagoras triplet. Find the Pythagorean triplet in which one of the number. We'll go with exercise sums, children. Today you are going with exercise 5.2 as a homework, children. Please do it. I am not going to teach much more. Today I was a little not well, children. So I did not take class, but I don't want to miss my class. So I continued with my class. We'll stop today. We are going with the Pythagoras triplet. One more condition is there. That part we will discuss in next class. Because any one of the number is given 12, in that case, how you supposed to equate? For which number you are going to equate, you need to take certain decisions. Please go with first bit as a homework and second bit we will see in next class. Okay. That's all for the day, children. Any doubts, please let me know.
Okay, ma'am.
Any doubts, children? Any doubts regarding to the class?
No, clear.
Fine, children. Shall we end up the session? Please take the first bit as a homework and do it and come back.
Okay, ma'am.
Bye, children. Have a nice day.
Bye, ma'am. Thank you, ma'am.